and welcome back to NTMAU. This problem is Semester 6 Advanced Math Problem 12, 287-50, right there. Okay, when we got to solve for a problem like this, it's the standard usual thing that we always talk about, and that is go for what you know. So you know that you have a distance from here to here of 2 inches, 273 thousandths. And you have a distance from here to here, because what you're going to do is you're going to take this and subtract this from it. That's going to give you this distance here, okay? Let's just project this out this way. Let's project this out this way. Let's solve for this. All right. Now, when you're going to solve for this, put a few arrows in here so that you know that that's a dimension line that you got to solve for. You're going to also have a connecting point here. That's your hypotenuse. And I need you to solve for this one too. And in the process of doing that, what you're going to get is the hypotenuse of that angle, but it's going to be a connecting point for another one. So the next one you're going to have, the next piece that you'll have on this, is going to be one more angle. And that's going to be coming off of this down to here. And from this one down to here, to where they're saying the y is. Now, we know that our distance from here to here is this 3 inches, 520 thousandths, and it's 3 inches, 520 thousandths here. So here's your angle, or here's the rest of this thing here that we're looking for. And the rule, math rule that we've become familiar with, is anytime that you have two sides that share the same plane, they have to be congruent, right? Remember that one? Well, there's our angle right here. There's the 90 degrees. So we know we have this, and we know we have this, and we know we have this. So all you're going to do is you're going to solve for this hypotenuse. Once you have this hypotenuse, you're going to divide it into two. That's going to tell you how much it is from here to here. Okay? All right, so that's going to leave us just one more angle to solve for. This is a relatively easy problem. And the one more angle is going to be the distance from here straight up. Don't pay attention to that other line that's there. It's not in the right spot. All right, I'm going to bring this one over. And I'm going to share this same plane coming down here on this hypotenuse here. Okay. Show the same one as the green surface. Now, I'm going to solve for this because I know that I have this hypotenuse here. I knew what I had here. I can find out, I've got this hypotenuse here. I can find out what this angle is here. And I can solve for this angle here. Because we're going to solve for this angle right inside here. Right there. Let me get a good pencil on this thing so we can show this the right way. This is going to be an angle here. Alright. I want to solve for this angle here. And we want to solve then for this angle off this green one here. So the first one, this one here, is off the blue. This is the blue angle. I should have put that in blue, but you get the idea. So we're going to solve for this surface on the blue. We know what this is. Okay, we did simple subtraction on the blue triangle. And we came up with this surface. We're going to get this hypotenuse. We want to solve for this angle here. Then what we want to do is on the green triangle, once we come up with this surface here, this 90 degrees here, we're going to solve for this one. So then you take this one and subtract this one from it, and you're going to get this one right here. When you have this small little triangle inside here, you know that this is going to be a 90 degrees up inside here, like this. So just take this and subtract it from 90, and that's going to tell you what this is. When you know what this one is, you also know what the hypotenuse is coming down here. So solve for this straight line plane. And then all you have to do is take this straight line plane that's coming up and down here and subtract this 2 inches 500 from it, and that'll tell you what it is here. And it'll also tell you what this side is over here, because you can figure that one out too. That's going to be your adjacent side. Make sure that you solve for that being the adjacent side. Okay, so let me fix this up with some colors to make it match. All right, just as a review now, I've got them in colors so that they kind of match. So you've got this angle inside here. We knew that we took the 3 inches 520 thousandths from here to here, 3 inches 520 thousandths from here to here, and we have this shared plane on the blue triangle. We got the shared plane again by taking the 2.273, that's the distance from here to here, and this distance from here to here on this blue, which is the 2 inches 500 thousandths minus the 1 inch 125 thousandths here to here. So I have this distance and this distance to give me this distance. So a squared plus b squared equals c squared. Okay, we've got the blue triangle now. I'm going to solve for this triangle inside here with that information. That's angle A. That's an A. Okay. Then the next one we know that we've got the 3 inches 520 thousandths from here to here, 3 inches 520 thousandths from here to here. Connects. Anytime that you have two angles or two legs that are exact same and they share the same plane, they are congruent, meaning they are equal to each other. Therefore, this distance can be divided by 2. When I divide it by 2, that tells me what this distance is from this point to this point, or along this line right here. Okay? Then I want you to solve for this angle here, just coming right off of this right angle triangle. Simple as that. Okay, so we're going to stretch this in here. Let me put this up here in good colors for you. So again, I'm going to take this, I'm going to bring this like this. Here's going to be my new angle, and it's really not a new angle. It's going to be just the angle once again. Okay? And zoom. I'm going to solve for this angle. Forget about this one over here. You don't need this one. X, nothing. You don't need that one. That's just a come along. All right? So you're going to solve for this angle. Remember that this angle, here's your hypotenuse, here's your longest side, here's your 90 degrees over here. So don't use the wrong one. Okay? Then take this, side B, which is what I've got here, okay, minus side A. That's going to give you side C. That's just this small little angle inside here, because here's a straight line coming down here. Here's this line coming down here. That's going to give you just this small surface inside here. Then all you have to do is take 90 degrees, which is this here, and subtract C, this C right here. Okay, this one here, this here. Connect that. All right, that's that. That'll tell you what this is here. Now what do you have? Well, you have this length here. This length here is 3 inches 520 thousandths. You have this angle. You can solve for the opposite side. Just make sure that you know this is opposite, because here's the angle that you have inside here. So solve for the opposite side. Also solve for the adjacent side. And when you solve for the opposite side, that's the length all the way down. Then all you have to do is take this length all the way down, this whole red line here, whatever you come up with this distance here. Subtract 2 inches 500 thousandths from it, and that'll give you y. And when you solve for the adjacent side, that'll give you x. And that's all there is to it. Piece of cake, right? No problems at all. Okay, I hope you have a great evening, and we'll talk to you real soon. Take care.